All right, ladies and gentlemen, I'm going to do a couple of videos discussing the standard normal distribution. This particular video is problem number 30, and this is from the study guide that I sent out previously for chapters 6 through 9. Okay, so let's just read the problem here. X is a normally distributed random variable. It has a standard deviation of 2. Find the mean of X. So here's the distribution. Find the mean. So find this guy right here. If 12.71% of the area under the distribution curves lies to the right of 10.28. So this is 10.28, and what they're telling us is that 12.71% is to the right. And it is giving us what the mean is. So hopefully that's enough to help us analyze this problem. Okay, let me make a correction here. It does not give us what the mean is. That's what we're trying to find. So I apologize for that error. So find the mean is a call of the question. Okay, so here's how I wrote this up. This is the information that we're given, that it's X is normal. It gives us the sigma is 2.00. It says the problem calls for the following. Mu is 12.71%. Find mu if 12.71% of the area is to the right of 10.28. So I just drew a little cartoon here, kind of get myself organized a little bit. And here's the mu. That's what I'm looking for at 10.28. All I know is that 12.71% is over here. So here's our solution. We need to find the z. Now remember, this is a normal distribution. The standard normal distribution is the one that we usually transform everything to. We do an appropriate transformation and we find the standard normal distribution. So when I say z, what I'm looking for, or what I'm talking about, is the standard normal distribution. So these are all the x's. This is the x distribution. The z distribution would be, the standard normal distribution. And remember, the standard normal distribution has a mean or a mu of 0 and a standard deviation of 1. So they're two different distributions. Okay, so we need to find the appropriate z such that 12.71% is to the right of that z. Now remember, in a perfect world, we don't have to do this, right? In a perfect world, we'd have the ability, calculators or what have you, to do the calculation using the actual formula for the normal distribution. But in this world, it's just a little bit too hard to do that. And also, this is just a way to learn how to use these tables. Okay, so if 12.71% is to the right, that means that 1 subtract 0.1271 is equal to this, and that corresponds to what is to the left of 10.28. Okay, so in other words, you remember the tables always give you the area to the left of any of these numbers. Let's take a look at that. So here's our table E. So for any particular z value, it's giving you the area to the left. And we are reminded of that down here. Any z value that is given by this column here, and then this is the third digit. These values in here give me the area to the left of that particular z value. So now we'll look at, those were the negative ones. Here's the positive z's. Okay, same exact concept. For any particular z, to the left are these areas. So let's see how that helps us. Okay, so we want 0.8729. What value of z do I need in order to get 0.8729 to the left? Well, according to my notes here, it's 1.14. Let's see if that's true or not. Okay, 1.14, 1.14 is right here. Boy, it's hard to do this on the screen here. 1.14 is right here. 8729. 0.8729. Write that down. 8729. That's what we're looking for. Okay? So that's the appropriate z value that we're looking for. Okay. Now, it didn't ask me for the z value, right? It asked me, you know, what's the mu here? What is the mu of this distribution? Okay, but I'm going to use that. Here's how I'm going to use it. Remember, this is what we mean by this standard normal, this so-called z-score. The z-score is z is equal to the original random variable x, take away mu, all of that over sigma. When you start with the x's, if you do this transformation, you get the z's that you want. Okay, so now we have everything we need, I claim, because we know what z is, it's 1.14. We know what x is, they gave that to us in the problem of 10.28. And we know what the sigma is, that's 2. Now all of that comes from the problem. The problem right here says that the standard deviation is 2. It says that the x that we're concerned about is 10.28. Okay, that's the one we're looking for. So everything that we needed was given to us in the problem. Okay, so bounce back up here, and I'm hoping you're following along on the what I sent out to you. So if you plug all that stuff in to this formula here, now we have everything we have everything we need. We have one equation. We have one unknown. The unknown item is the mu. That's the only thing we're missing. So what do? We just solve for mu. We manipulate this guy right here until we get mu equals something. Okay, so now it's all over, but the manipulation, I multiply both sides by 2. That gives me 10.28, take away mu over here. I can... let's see, what do I want to do here? I'll take this guy and put it over here, and then take this guy and put it over here. So I add and subtract appropriately. That gives me 10.28, take away 2 times this, multiply it out, and I get 8. So mu is equal to 8. It's just a matter of doing the arithmetic, doing the algebra. Okay, so mu is equal to 8, which is A. That was the correct answer. And if you look at the answer key, that is the correct answer. All right. So it's always helpful to write yourself little notes, and that's what I did here. So I said to myself, okay, all right, that's fine. I solved that problem, but let's do this more generally. In general, I know that z is equal to this. This is just the definition. Z is equal to x take away mu, all of that over sigma. So how about if I just manipulate, multiply both sides by sigma, rearrange the terms a little bit, okay, and this is what I get. So in general, I could have just gone right to here. If I knew this identity here, I could have just plugged things in very, very quickly. Okay, so the key to solving this is to see that the appropriate z is 1.14. That's what solved the problem for us, was that z is equal to 1.14, and that, honestly, that just comes from the cartoon. I've told you guys so many times, I hope you listen to me, drawing these cartoons is half the battle. Okay, so that's the end of this tape.